In this lecture, we are going to discuss few questions which are very much relevant to the Pgtrb physics examination, which will be commencing soon. I discuss few questions and I will discuss the solutions for these questions also. If anybody, because there are 100 questions, there are two sets, there are 100 questions, and if anybody needs all the questions along with the solution, you please contact me through this WhatsApp number, and I will send the question paper as well as the solution through WhatsApp. The cost is just only 100 rupees. That's it. Now we will discuss the questions. Now let us consider this question. Find the total charge distributed in a circular disk of radius r if the surface charge density is given by sigma is equal to sigma naught cos square theta, where sigma naught is a constant. There are four options are given. Now, in order to solve this one, first you have to find the sigma. Sigma is equal to charge per area, because this is charge density dq by dA. So dq is equal to sigma times dA, where dA is the area, and for r theta coordinate system, so this radial coordinate system, the dA, the area is expressed by r, dr and d theta. Therefore, dq is equal to sigma times r dr d theta. Therefore, you are asked to find a q. So you have to integrate over dq, which gives the total value of q, which is integral of sigma r dr d theta. Sigma is given as sigma naught into cos square theta. So you just substitute this one. You evaluate the radial part of the integral, which is 0 to r, and the angular part is 0 to 2 pi. So this once of you integrate radial part, this will be r square by 2. So you will get r square by 2. If you evaluate the cos square theta d theta with the limit 0 to 2 pi, it will be pi. So option B is the correct option. Similarly, if we take another example, say this question number 46. Now here, find the magnetic field intensity produced at the point P if the current is flowing as shown in the figure. So the current is flowing along this direction and the semicircular path, again straight path, again there is a semicircular path. So this is the direction of the current. This is given. The four options are given. Now here the solution can be found like this. If we take this question 46, now you are asked to find the magnetic field intensity at the point P. So this point P is along the axial line of the straight conductor. So if it is any point along the axial line, B will be 0. The magnetic field produced due to the straight conductor is 0. Therefore, you divide this into four parts. This one is a B1, and another one is a B2, the semicircular one, and this is B3 and B4. So B1 will be 0 because this point is along the axial line. Similarly, B3 is also along the axial line. So the magnetic field produced at this point P due to the wire, this is straight wire along the path 3. B3 is also 0. Now let us calculate the value of magnetic field intensity due to the semicircular path 2. This value is mu 0 I by 4 pi r. So here this r is the radius, r1 is the radius, into pi. because this is the clockwise direction, so this is pi. Now, if we take the fourth one, before, again mu 0 by 4 pi r, here for the anti-clockwise direction the current is flowing, here this value is equal to minus pi. So, if you add all the 4, B is equal to, you have to sum all these things, mu 0 I pi divided by 4 pi into 1 by r1 minus 1 by r2, where here r2 is the radius of the larger semicircle, which is larger than the R1. So option A is a correct one. So if questions are given, the solution can be is also given. Now you take a few more problems in say the classical mechanics. Say if we take question number 25. So these are the most probable questions that may be asked. The Lagrangian of the system is given as L is equal to half m x dot square plus m x dot y dot. The Hamiltonian is 4 options are given. Now you must be careful. Here x dot square, here there is a cross term. If it is a cross term, we must be very careful. So for this, you have to use this method. Say L is equal to, write down the expression for L. You know PL is equal to partial dl by dx dot. So if you differentiate with respect to x dot, you will get Px. Similarly, Py is equal to partial dl by dy dot. So if you differentiate with respect to y dot, you will get another expression. So this expression gives x dot is equal to Py by m. Now Px is equal to m x dot plus my dot. So here it is given. You substitute for x dot, which is equal to Py by m. So here substitute for Py by m, and if you simplify, you will get y dot is equal to Px minus Py by m. Now this is the standard procedure. H is equal to summation over I Qi dot Pi minus n. Qi dot here this is x dot Px plus y dot Py. There are two coordinates, x and y coordinates. So here, if you perform the summation, you will have two terms, x dot Py plus y dot Py. L is equal to minus L. L is given here, so you substitute the value of L here. Now you substitute the value of x dot, because you have calculated x dot as well as y dot. Just substitute in this expression, and if we simplify, the Hamiltonian can be easily obtained. H is equal to Px Py by m minus Py square by 2m. Similarly, you consider equation say 28. For example, if we take example 28, if a particle is moving under a central force, F is equal to minus k by r square. So central force, this is the expression for the central force, which is independent of theta and phi. Now the Poisson bracket between the two variables r and r dot is. So 4 options are given here. Now the solution is, now if we take the solution, if a particle is moving under a central force, find the Poisson bracket. Now here for F is equal to given. So what is the potential? Potential energy is equal to minus integral of F dot dr infinity to r. So this is important. So you must remember this expression. Potential energy is equal to minus integral of F dot dr between the limits infinity to r. We substitute the value of F, which is minus k by r square here. So then if you integrate, you will get the potential energy is equal to minus k by r. So what is the Lagrangian? Lagrangian is equal to T minus V. What is T? Because this is a r theta system, radial system. So the kinetic energy is equal to half m into r dot square plus r square theta dot square. So this is the expression for the kinetic energy, and potential energy we have already calculated, minus k by r. So T minus T. So since there is a minus here, so if you substitute here, it is a plus k by r. So the Lagrange is available here. Then you are asked to find h. Now here the problem is very simple. Now if you are not having any squared terms in r dot as well as theta dot, the only squared terms are there, no cross terms are there. R dot theta dot, that product term is the cross term that is not present. If cross terms are not present, then Hamiltonian can be obtained very easily. Just you write down half here, the first one, then you may open the bracket. Now if this is r dot square, here you put pr dot square, and your m, the coefficient of r dot square m, that must be placed in the denominator. Similarly here, theta dot square, if it is you can write p theta square. So this is a trick you have to follow, so that you can do it very quickly. Theta dot square, so this is a p theta square, and what is the coefficient of theta dot square? This is m r square. Apart from r, m r square is the coefficient, you put this coefficient in the denominator. So this is h is equal to half into pr square plus divided by m plus p theta square by m r square, and the here this is t the minus k, and here this is the potential energy term. You write down the potential energy term, and you have to change the sign. That is important. You have to change the sign. If it is a plus, and you have to put minus. If it is a minus, and this is a plus. So this is a trick that you have to follow, so that you can write down the Hamiltonian directly by looking the Lagrange, so that you can do this problem very quickly as well as correctly. Now once if you write down h, then what is r dot? R dot is equal to partial dh by t dpr. So h is available. If you differentiate with respect to pr, you will get pr by m. So r dot is equal to pr by m. Now you are asked to find this bracket, this Poisson bracket between the two these variables r and r dot. So you first write down r dot you have evaluated pr by m. So this is a pr by m. Now the 1 by m is a constant that can be taken outside, and you have to find the Poisson bracket between r and pr. Since r and p suffix are the canonically conjugate quantities, therefore this must be equal to 1. So we know r pr is equal to 1, x px is 1, y py is 1. So this is a canonically conjugate variable which is present within the Poisson bracket, that must be 1. So once if we substitute the expression, becomes 1 by. So you have to use a trick in order to solve this problem very quickly. So there are 100 questions are available for the first 5 units. There are 2 questions, 50 plus 50, and most of these questions are very much relevant to the Pgtrb examination. So this is the final last moment preparation. So if you do this preparation at the last moment, because the question as well as the solution is given, just once if you look it out, then you can do more problems correctly. So if anybody wants the 100 questions, you please contact me through this phone. I will send it. You also send your WhatsApp number. If you contact me, I will give you the account number so that you can pay the amount. The amount is just 100 rupees. That's all. Not a very profitable work. Anyhow, for a small contribution I need. So you just pay 100 rupees. Then I will send all the 100 questions through your WhatsApp number. These questions are very much useful for your coming Pgtrb examination. Thank you.